Welcome to Indian Academy of Maths Tutor. So in this video, we have maximizing the area of the rectangle issue. And we have been given certain constraints. The length of the rectangle is 120 centimeter. That is, its parameter is 120 centimeter. And we are supposed to find the area of the rectangle such that with the given parameter, the area is maximized. Now, before going ahead, the question is, why is this a calculus issue? Now, because the title of my video says calculus, that's one thing. But if you read the question carefully, whenever you see the word maximum or minimum, that's the first light bulb moment that would hit you, that this has to be solved using calculus or derivative. So let's take an attempt and start solving. So it says the parameter is 120 centimeter. So that means, let me write the first equation, step 1. It says the parameter. So the parameter of triangle, as we know, will be 2 times L, which is the length, plus X, which is the breadth here. And it says this is equal to 120 centimeter. Let me establish that L is the length and X is the breadth, and they both are variables. And both are variables. Okay. Now this becomes an algebraic equation. If we divide both sides by 2, this will become L plus X is equal to 120 by 2, which is 60 centimeters. Okay. Now for step 2, we are going to find the area. Step 2 will be area, which will be in centimeter square, remember? And let's suppose I write area as y, just for the fun of it. So area is length into breadth. In our case, this will be L dot x. Okay. Now here we know that from 1, L plus x is 60 centimeters. And in step 2, we have 3 variables, y, L, x. And it's asking us to maximize this, right? Maximize y. In order to do that, we'll have to reduce one variable, either L or X. So in order to do that, what I'm going to do is, from 1, I'm going to write from 1, L plus X is equal to 60, or simply L is equal to 60 minus X. Now this thing, this will go here. So now the area will be L, which is 60 minus X times X. And if I open the bracket, this will become 60x minus x squared. And this is all in centimeter square. Let me scroll down. Let me scroll it down. So y is 60x minus x squared. Okay. Now this looks a very familiar form. Y is as a function of x. Okay. Now I'm going to take the derivative on it. Let's go to the calculus. Since it's asked on maximize y, I'm going to take dy by dx. But before I go with dy by dx, let me graph this equation. And the reason I'm saying I want to graph it, see, 60x minus x squared is a quadratic equation which looks like a parabola. So for those who are a visual learner, yeah, so I have y here and x here, and I have y as 60x minus x square. So you can see first, this is a parabola. Second, since we have minus, this will be a downward parabola. Okay. Third, this doesn't have a constant. Generally, a form of parabola is ax square plus bx plus c. Here c is 0. So I can assume that here y as a function of x, which is 60x minus x square, this parabola will pass through x is equal to 0. So this is origin. At x is equal to 0, y is also 0. So if I draw an approximate parabola, this is 0, 0. And if you look at this thing, just by solving, y could also be written as, if I take x common, 60 x minus x times x. So for x is equal to 0 and x is equal to 60, y becomes 0. Y of x is 0. So if I put y as 60, this becomes 60 times 60 minus 60, which is 0. So this point will be 60, 0. Again, this is just for visual learning, okay? Let me erase all that. Now, if you take a close look, this point, which is the vertex of the downward parabola, is the maximum point. This is what we are supposed to find. At what value of x will y be maximized? Okay, for this we are using calculus. Now let's go back. We are going to maximize dy by dx. So here dy by dx will be d of 60x minus x square by dx, which will become 60 minus the 2x differentiation will be 1. Here x square, 2 will come down and x. And because we want to maximize dy by dx, this should be equal to 0. Let me use another color. This will be 0. Now we sure know that this is maximization point, not minimization. First, because I showed it using the graph. Second, if you do a second order derivative, the rule in calculus says if you do a second order derivative, this is just for your knowledge. Let me write it here. d2y by dx square, which will be minus 2. Since this is negative, your main function, which is y, will be maximum. Had this being positive, your y would have been minimum. Okay, this is second order. So there are two methods to see about maximization. Either you look at the graph, visual representation, or you do a second derivative, which both ways show this is a maximizing value. So let's equate this thing to 0. So 60 is equal to 2x, or 2x is equal to 60, which finally gives us as x is equal to 30. Now let's go back to the graph. So for x is equal to 30, this point, let's call it 30, 0, which happens to be the midpoint, okay? Y is your y is x dot 60 minus x. which is 30 times 30, which is 900 centimeter square. Units are important, okay? 900. Remember, L is also 60 minus x. So this will be 60 minus 30, which is 30 centimeter. So when L is equal to x, this maximizes the area. This is again a feature of calculus. Okay, this need not be always, but in most conditions, at a point where L and x kind of are equal, if you see in many questions, the point maximizes, but this thing varies from question to question, right? So this is our area, 900 centimeter square, for which the area is maximized. Now let's understand this thing using logic. Okay, so let me use another pen. So remember, we have written the equation as x plus L is equal to 60, right? So I'm going to take random numbers for the area and do a hit and trial, plug in, and see what's the area, so that we make sure that this is the maximized area, just for learning, okay? Let's suppose if x is 10, this has to be 50, length will be, sorry, my bad, total will be 60, this has to be 50, right? Now 10 times 50 is 500. Now let's suppose x is 20, length will be again 40, 20 plus 40 is 60, and this is again 60. Length will be 20 times 40, 800. Area is increasing. Let's suppose x is 25, L will be 35, because 25 plus 35 is 60, right? So your area will be, let's do 25 is 30 square minus 5 square is 900 minus 25, which will be 875, right? Area is maximizing. Let's do 29. Let's do 29 and 31. 29 plus 31 is also 60. That will be 30 square minus 1, which is 900 minus 1, which is 899. Ooh, the area is increasing. Now we all know that at 60, at 30 comma 30, let me use another pen. At 30 comma 30, area is maximum, and this is 900, right? Now, if you decrease it, that would be just the exchange of values. What I mean by that is, if you make x as 35 or 40 or 50, let me write in a sequence, 35, 40, 50. Here L will be, when x is 35, L will be 25. So again, total 60, 35 plus times 25 is 875. I suppose that's 875. 30 square minus 5 square. 40 and 20, 60. 40 times 20 is 800. 50 and 10. 50 times 10 is 500. So you can see it manually that as we go down, as the value of x increases up to 30, the area increases. After that, it decreases, right? That's what is also being shown by the nature of the curve. Here, this is the saturation point, you see. Here, as x increases, y increases, and as x decreases, you let me use another pen. For as x decreases, you see, for here and here, y would decrease. Y would decrease, right? For this point and this point, we get the same y, but it decreases. So this is the beauty of calculus. Using derivative, you are able to find that exactly at midpoint, when length and breadth are same, the area maximizes, which is 100 centimeter square, right? and we used a visual example of hidden trap. Well, if you have any more questions, you can reach out to me. Uh, you have details in the description. Thanks for your time and see you again.